Logical errors. Three types of errors. Syntax errors are which type of errors? Exceptions are runtime errors. How many types of exception? Two types. What are those? Checked, unchecked. Which are checked? Which are derived from exception class. Which are unchecked? Runtime exception. Which type of exceptions are mandatory to handle? Checked exception. If you don't handle, what will happen? Compile time error occurs. Is it compulsory to handle unchecked exception? No. Why? System handles implicitly. What purpose programmer has to handle? To display user-friendly error messages. Okay. See, how many keywords we use in exception handling? 5. What are those? Try, catch, throw, throws. Finally, yesterday, one program I given. Try, catch, throw, throws. 4 keywords I used in that program. 4 keywords. This program you have seen yesterday. Now here, negative number exception. Is it checked exception or unchecked exception? Unchecked exception. How do you know? Here, runtime exception. Okay. Is it compulsory to handle? No, it is no need to handle. Now, if I compile, it will compile. Java C demo.java successfully compiled. Okay. Now, here, if I write just exception, it is which type now? Is it compulsory to handle? If we don't handle, what will happen? Compile time error occurs. See, occurred. Now, I'll explain what is throw, what is throws. I would explain. Next nodal. Throw keyword. Nodal. Throw keyword. Throw keyword. Nodal. It is used to pass an object of exception class to a catch block. It is used to pass an object of exception class to a catch block. It is used to pass an object of exception class to a catch block. So throw keyword, it is used to throw an object of exception class to a catch block. It is used to pass an object of exception class to a catch block. Now, in this program, if I write exception, it is compulsory or to handle. I'll handle. Try, catch, negative number exception. System.err.println any. You'll write. Now, what will be happen? See, demo class loaded, open brace executed, main method called, open brace executed, try block executed. At the command prompt, whatever you pass received string format to integer format converted, demo class object created, that object referred by T with that cube method called. The value, whatever you passed, received here. It will check greater than 0. then Q printed, else here object created, here object created. This object passed here. It will receive. See, throw. It is used to pass an object of exception class to a catch block. Throw keyword will throw the object. Catch keyword is going to catch the object. Now, what will happen? Negative number exception NE equal to new negative number exception. Like this, it becomes. That object assigned to reference. Okay. Like this, it will become this one. This throw keyword will throw the object. Now, where we use this throw keyword? If you define your own exception, then only you have to throw. But already thousands of exceptions already prepared by Java developers. Those exceptions already they have thrown. We are not going to write throw keyword. If you want to create your own exception, then you have to write throw. But generally, thousands of exceptions already prepared by Java developer. No need to create exception, no need to throw the exception. This is only understanding purpose I given on program. Okay, how exception handling mechanism working. That process you understood with this example. That purpose I given. So in future, you are not going to create exception. Thousands of exception already prepared by Java developers. That is only you are going to handle. So further, we are not going to create exception. We are going to handle exception only. Only handling. Okay. So this throw keyword further not required. Throws keyword. What purpose? Note. Throws keyword. It is used to apply an exception to a method, and it is also used to handle exception. It is used to apply an exception to a method, and it is also used to handle exception. It is used to apply an exception to a method, and it is also used to handle exception. It is used to apply an exception to a method, and it is also used to handle exception. See, number format exception, they apply to parseInt method. Like that, here, negative number exception, we apply to cube method. Number format exception, they apply to parseInt method. Negative number exception applied to cube method. Like that, there are so many are there. Say Java P, java.lang.string. Here, this is one method. This is one method. For this exception applied. Okay. This is one method. Resolve constant describe. One method. Throws java.lang.reflective operation exception. This exception, they apply to this method. Integer class here. Here, parseInt. Now, here, number format exception applied to parseInt method. Like that, myself, this exception applied to cube method. Okay. This exception I applied to cube method. That is applying, but not only applying, it is used to apply an exception to a method. I applied. It is also used to handle exception. Handling means actually try catch, but with throws also possible. How? Next, write it. There are two ways to handle exception. First one, by using try and catch blocks. Second one, by using throws clause. First one, by using try and catch blocks. Second one, by using throws clause. CLAUSE clause. Because it is not a block, it is clause. One line will write clause. Open brace, close brace will write block. So there are two ways to handle exception. One is by using try and catch blocks. Second one by using throws clause. Now, with the try catch block also possible, with throws also possible. So try catch, multiple catch block, single here, throws also possible. You can write, there are two ways to handle exceptions. Throws also multiple exception possible. Now, there are two ways to handle exception by using try and catch blocks, by using throws clause. Now, just observe this program. If I don't try catch block, will it compile? Will it compile? No. Now you observe unreported exception, negative number exception must be caught or declared to be thrown. System only showing two. What system saying? Either write try catch block or write throws. Must be caught nothing but try and catch blocks. Declared to be thrown nothing but throws clause. So what system saying? Either write try catch block or write throws. Must be caught try catch blocks. Now, first one. First one, by using try and catch blocks. Example. There are two ways to handle exceptions. First one by using try and catch blocks. Second one by using throws clause. First one by using try and catch blocks. Second one by using throws clause. Now first one by using try and catch block. Example. Here I'll write try catch block. Try catch negative number exception. Now what you do is only this part write it. Main method. Example, write this one. This is a try catch block example. Write this one. Is it over? This is by using try and catch blocks. So here try, here catch. This catch block will catch. This catch block will handle. This is a handling exception. This is one way. One more way, throws. Okay. Now, if I write like this try catch block, program successfully compiled. Okay. But if I remove try catch blocks, error comes. That error, unreported exception, negative number exception must be caught or declared to be thrown. This is your scene. Declared to be thrown. I'll declare with throws. Here. Throws negative number exception. If I write, now it will compile. File, save. But what's the difference? Now you observe. You first you write this one, second one. By using throws clause. Example. By using throws clause. By using throws clause. Is it over? Write only main method code. Just write only this part. Example. See, if you write try catch block, compiled. If you write throws, compiled. Now, with the try catch block, exception handled. But actually, the word throws meaning again throwing only. The word meaning throwing only. But how it will handle is, if you write throws, compiler implicitly provides try catch blocks. That means at last again try catch block only handled. Okay. So actually, which is throwing? Cube method throwing. Cube method throwing. Main method, if you write try catch block, main method handled. But now main method also throwing. Who will handle? Try catch only. But where is try catch? Implicitly comes. See, actually, if you write throws, actually we have to write try catch block. By writing throws, what we are saying to compiler, I am not writing try catch block, you write the meaning. Okay. So if you write throws, that meaning is we are informing to compiler, I am not writing try catch block, you write try catch block. Then compiler will write try catch block. Okay. That type. If I assign one work to you, you will assign to one more person, that type. Okay. Actually, we have to handle. We have to write try catch block. What we are saying to compiler, I am not writing, you write. That meaning. So in this approach, Java compiler implicitly provides try and catch blocks. Write it. In this approach, Java compiler implicitly provides try and catch blocks. In this approach, Java compiler implicitly provides try and catch blocks. In this approach, Java compiler implicitly provides try and catch blocks. In this approach, Java compiler implicitly provides try and catch blocks. See, if you write throws also, at last try and catch block will be there. Now, when we have to use this one, when we have to use that one, that depends upon situation. Suppose I want to handle, okay? Now, here, now, is it compulsory to handle? Is it compulsory to handle? Yes. Only handling, like this better. You want to write user-friendly error message. Is it possible with this one? Then try catch. Suppose you want to handle, but you don't want to display user-friendly error message. In that situation, throws. You want to handle, you want to display user-friendly error message. Then try catch. Situation. So, suppose if you don't handle, will it compel? Will it compel? No. Compulsory you have to handle. Either you have to write try catch block or you have to write throws. Then only your program will compile. Now you don't want to display user-friendly error message. Just you want to handle. In that situation, throws better. But you want to display user-friendly error message also. In that situation, compulsory we have to go for try catch block. Otherwise, not possible. Okay. Like that, throw keyword, throws keyword. See, in try block, what we are going to write? In try block, task code. In try block, we are going to write task code. In catch block, what we are going to write? Error message. Throw keyword, what purpose we use? To pass the object to catch block. Throws keyword, what purpose we use? To apply to handle. This exception I applied. Here handle. So here different, but writing is same. Here inside method body throw is there. That means applying. Inside method body throw is not there. It is handling. Like that you can understand. Okay. Now, like this, further, what you have to do, just observe. I'll show you one class. Java P, Java dot something I'll open. File input stream. Now, here. Here, it is class name. It is package name. Package, subpackage, class. Okay. Now, is it constructor or method? Is it constructor or method? Constructor. What is constructor? Same name, which has class name, method name, same. Next, no return type. Now, is this constructor accessible? Yes. How do you know? Public. Is it default constructor or parameter constructor? Parameter constructor. How do you know? string parameter is there. Will it throw exception? Yes. How do you know? Throws keyword. Which exception? File not found exception. Like this. Whether exception is there or not, can you identify or not? How will you identify? Throws keyword. Now, if I open any Java library, constructor or method, if I ask whether will it throw exception or not, if I ask, you can identify whether exception is there or not. No? After that, you have to identify whether it is checked or unchecked. Okay. Now, file not found exception. Is it checked or unchecked? How to identify? How to identify first of all? Now, first, what is checked exception? If the class is derived from exception class, that is called checked exception. What is unchecked exception? If the class is derived from runtime exception, that is called unchecked exception. Now, either it is checked exception or unchecked exception. How do you know? We have to see the library. That is derived from exception or runtime exception. Out first, you should know. That's what this profile we have to open. Okay. Now, Java P, Java.io. File not found exception. File not found exception extends IO exception. IO exception extends exception. That means checked or unchecked? Checked. But whether it is checked or unchecked, how to see? You have to see the library. Okay. Now, whether it is checked exception or unchecked exception, how to identify is there are three ways. It is one way. It is one way. Okay. See, suppose one more. Here, one method is there. Method name. What is the method name? Resolve constant describe. Okay. Now, is this method accessible? Is this method accessible? How do you know? Public. It is public method. Anywhere you can access. What is the return type of this method? What is the return type? Object. It is package name. Return type is object. How many parameters are there? One. You studied this dollar symbol. Inner class. Studied in inner class? Inner class. Demo $1. It is class. It is inner class. Okay, like that. This is parameter inner class type. Will it throw exception? Yes. Which exception? Java.lang. Reflective operation exception. Is it checked or unchecked? Checked or unchecked? We have to see the library. If I give option, you'll select one answer. Blindly or select. Blindly don't select. First answer is you have to check the library. Okay. Now, how to check? Java P, Java.lang. Reflective operation exception. Reflective operation exception extends. That means checked or unchecked? Checked. Is it checked? First of all, if I give any library method, whether it is throwing exception or not, can you identify or not? Yes. How will identify? Throws keyword. After that, whether it is checked or unchecked, can you identify or not? Yes. How will identify? By using Java P. Okay. Java P command, you'll understand whether checked or unchecked. If it is checked, write try catch. If it is unchecked, don't write. Further, that is only our duty. Remaining are not required. While developing application, compulsory one library method required. Any application, Without library, welcome program also not possible. System.out.println also library only. Okay. Without library method, without predefined method, welcome program also not possible. Every program we are using library. While developing applications, we required library methods. That method throws exception or not, find out through using throws keyword. If exception is there, checked or unchecked, find out. If it is checked, write try catch. Unchecked, don't write. That is only further. Okay. Now, this is one way to identify checked or unchecked. But one more way is there. Don't see the library. No need to see library. Write the program, compile. If we get unreported exception, must be caught or declared to be thrown. That meaning checked exception. So no need to see the library also. Write the program, compile. If you are getting error, unreported exception, that exception class name, after that must be caught or declared to be thrown. This message appears, no? Then you can understand it is checked exception. We have to write try catch block. That is one more way. Okay. One way you can see the library. With library you can identify. One more way, no need to see the library. Don't write try catch, compile. If you are getting must be caught, then understood. You can understand it is checked exception. Okay. That is one more way. One more way possible with knowledge. Like I given one point. All application specific exceptions are comes under checked. General exceptions are comes under unchecked. See, IO exception, it will occur only input output related programs. That is application specific. Interrupted exception, it will occur only in multi-threading. SQL exception, it will occur only in JDBC. Servlet exception, it will occur only in servlets. JSP exception, it will occur only in JSP. Like that, topic wise. That is when you will understand after completion of core Java. Okay. Now, particular topic only occurs. Other places it may not occur. That type of application, that type of exception is checked. All places may occur unchecked. Now, number format exception. Here also occurs, multi-threading also occurs, JDBC also occurs, servlets also, JSP, everywhere may occurs. That is unchecked. Array index out of bounds exception. Many places we use arrays. Then unchecked. Arithmetic exception. Many places may occur. Unchecked. Which are general, which are common to all applications. That is unchecked. Which are specific to application. Checked. Like that you can identify. This point already given. Last point in the checked, unchecked. Okay. Like that you can identify. Now, here. Now, is it checked or unchecked? Checked. If it is checked, Java compiler, what it will do? It will search for try catch or it will search for throws. In these two, anyone should be there. If not there, compile time error. So compiler will search for try catch blocks. Compiler will search for throws. That's what this category of exceptions are called checked exception. It is going to check. Compiler checking. That's what checked. If unchecked exception is there, compiler will not check. That's what unchecked. Now number format exception. Your compiler will not going to check try catch throws. That is unchecked. Like that. That's what checked, unchecked words. Why it is called checked, why it is called unchecked. Compiler checking. That is checked. Compiler not checking. Unchecked. Got your point? Now here, throws also you have seen. Okay. Now, total how many keywords are there in exception handling? 5. What are those? Try, catch, throw, throws, finally. One more reason. That is. Next, finally block. Next one, finally block. Finally block. See, further what we have to do is, now almost exception handling is going to complete. After exception handling, application part begins. Application time, compulsory we have to use Java library, Java API. Compulsory we have to use. Without API, one application also not possible. Okay. At that time, whether that method or constructor throwing exception or not, you check it out. If throws keyword is there, there is an exception. Throws keyword is not there, there is no exception. Like that you can identify. After that, whether it is checked or unchecked, find out. 3 ways. One way, see the Java library. One more way, compile. One more way, with knowledge. Like that, any one way, use, identify. After that, if it is checked is there, write try catch. Unchecked is there, don't write. That is only further. Okay, further we are going to use try catch throws. That's it. Okay. Last one, finally block in the exception handling. Note down. It is used to perform clean up activities. It is used to perform cleanup activities. Cleanup activities are closing a file, comma, closing a socket, comma, closing a database connection, dash dash, etc. Cleanup activities are closing a file, comma, closing a socket, comma, closing a database connection, dash dash, etc. Cleanup activities are closing a file, comma, closing a socket, comma, closing a database connection, dash dash, etc. Finally, block is executed even exception occurs in a program. Finally, block is executed even exception occurs in a program. Finally, block is executed even exception occurs in a program. See, it is used to perform cleanup activities. Cleanup activities are nothing but closing a file, closing a socket, closing a database connection. See, it is one file. Some content is there. This file you open for reading. You open for reading. After reading this file content, this is you have to close. If you don't close, memory leakage problems comes in a project. This memory, maybe it is going to be stored in opened files. Whatever in a RAM it is there, that may be stored in a file. That type of problems may occur in a real-time projects. That's what always you have to close. Whatever you open, you need to close. Suppose, for example, you want to shut down Windows operating system. Now already 5 programs are running. Edit Plus, okay, Edit Plus, browser, Zoom software, command prompt, and Notepad. If I shut down, will it shut down? One dialog box comes. These are already open. First you close. Okay. And shut down anyway option also will be there. Shut down anyway option also will be there. Whatever it may be, you want to shut down. Then actually, what is the process? First you have to close. After that, you have to shut down. That is only right way. If you directly shut down anyway means Windows operating system sometimes maybe some files may be missed, some files may be corrupted. That's the reason it will show on dialog box also. Shut down anyway or close, cancel. It will ask. Then what you have to do? You have to click cancel. You have to close this all. Then you have to shut down. That is only right way. But shut down anyway means present okay. Next time when you open Windows, it may or may not works properly. That type of problem may comes. That is the reason while developing projects also, what are the resources already open? After completion of your task, you must close. You must close. That code you must write in a finally block. You should not write in a try block. You should not write in a catch block. You should write in a finally block. Why? Say, suppose say, suppose here it is on file. This is a file content. Suppose this file name is abc.txt. Now, here, try block, what will write? Try block, what will write? Task code. Some code I'll write. Try block, I'll write some code. My task is I want to display file content. I want to display file content. That code I'll write. Catch something exception here one error message I'll write. Now, my task is abc.txt file content I want to display on monitor through Java program. Then what we have to do? We have to open a file. Some code we will write. We have to read this content. We'll write some code. At last, we have to close this file. Suppose here, if you write closing code, if you write here, suppose file is opened. While reading data, exception occurred. Control jumps to catch block. Is it file closed? No. That's what we should not write in try block. Now, what is happened is here, this file opened, this content, it will read, file closing, I written. File is open, content it will read and displayed and closed. Successfully executed. It is not a problem. Suppose file is open, while reading only exception occurred here. Control jumps to catch block. Then this code is not executed, no? File is not closed. That's what we should not write in try block. Suppose if you write in catch block, now file opened, it will read, displayed, everything okay. But exception is not occurred. Control will never come to catch block, no? Then file is not closed. So if I write in try block, what is the problem? If exception occurs, file is not closed. If I write in catch block, what is the problem? If exception not occurred, file is not closed. That's what you should not write in try block. You should not write in catch block. Where we are write finally block. This, if you already opened file, if you want to close, use finally block. Already open socket, if you want to close, nothing but network programming. Sockets we have to create. Closing a database connection, database programming. Already open connection, close. That code you have to write in finally block. Finally block is executed even exception occurs in a program. Exception occurs also closed. Always closed. Now try block successfully executed. Exception is not occurred. After that, finally block. Closed. Exception occurred. Control jumps to catch block. After catch, finally also executed. At last, it is executed. That's what that code we have tried in the finally block. Okay. This example today not possible. Either closing a file record or closing a socket record or closing a database connection record. Then you'll understand. Okay. That is in further I'll explain. Next topic, that one only. Closing a file comes. Okay. Up to here, whatever you learn, it is language. Java language. Okay. Now application part begins. Up to here, exception handling completed. With this knowledge, you can develop applications. Okay. See, still many topics are there. Only language completed. See, these are the topics left. Java streams and serialization. It is one topic. Next, network programming. Okay. Next, collections framework and generics. Next, multi-threading and synchronization. Next, new features from JDK 1.1 to JDK 20. These are left. Okay. Java streams and serialization, network programming, collections framework and generics, multi-threading and synchronization, new features from JDK 1.1 to JDK 20. Okay. These all you are going to see. Still these topics left. JDK new features only, so many features are there. Already Java 8 features, only 11 features are given already you have seen. Okay. So many features are there. Collections framework, still minimum 1 month required. Minimum 1 month. Okay. Minimum 1 month required still. These all. Now, finally block. In this topic only I'll explain. In this topic only I'll explain. Okay. Next. Java streams. Note on. Java streams. Concurrent package comes under collections only. Java streams. Note on. A stream is a flow of data from source to destination. A stream is a flow of data from source to destination. Java streams. A stream is a flow of data from source to destination. Here, source can be a keyboard, comma file, comma client, comma server, dash dash, etc. Here, source can be a keyboard, file, client, server, dash dash, etc. Here, destination can be a monitor, file, client, server, dash dash, etc. A stream is a flow of data from source to destination. Here, source can be a keyboard, file, client, server, dash dash, etc. Here, destination can be a monitor, file, client, server, dash dash, etc. Say a stream is a flow of data from source to destination. Here, source can be a keyboard, file, client, server. Destination can be a monitor, file, client, server. Suppose here, keyboard is a source, monitor is a destination. I'm typing data from keyboard received by monitor. No? Keyboard is a source, monitor is a destination, data traveled keyboard to monitor. That is called stream. Now, whatever I'm typing from keyboard received by monitor. So, data traveled from keyboard to monitor. That is nothing but stream. Now, from file, it will come to monitor. That is also stream. From keyboard, I'll write to file. That is also stream. Client is in Hyderabad, server in US, data travel, client to server. It is nothing but stream. Like that. Okay. Next, write it. In Java, streams are divided into 3 categories. In Java, streams are divided into 3 categories. First one, console input output streams. Console input and output streams. File input and output streams. Network input and output streams. In Java, streams are divided into 3 categories. First one, console input and output streams. Second one, file input and output streams. Third one, network input and output streams. In Java, streams are divided into 3 categories. Console input and output streams, file input and output streams, network input and output streams. See, total number of categories 3, but there are 6. Console input stream, console output stream, file input stream, file output stream, network input stream, network output stream. Okay. Now, is it over? See, how many combinations possible you observe? First combination, suppose it's a monitor. It is a keyboard. If you type data from keyboard, directly it will not come to monitor. First temporarily stored in the RAM. Okay. Whatever you type from keyboard, data received by RAM. That data displayed on monitor. Then here displayed. Keyboard to RAM. It is called console input stream. RAM to monitor. It is called console output stream. In C language, we are calling standard input stream, standard output stream. Okay. Keyboard is called standard input device. Monitor is called standard output device. But in Java, they given terminology console input stream, console output stream. Okay. Say from keyboard you are typing the data received by RAM. That data again transferred to monitor. So it is input, it is output. Keyboard to RAM, RAM to monitor, data traveled. So this stream is called console input stream. This stream is called console output stream. Suppose second one. It is one file. It is one file. This file name. One file abc.txt. One file. This file content I want to display on monitor. First it comes to RAM. File is in hard disk. File is in hard disk. File to RAM. It is file input stream. RAM to monitor. RAM to monitor. Console output stream. Here also RAM to monitor. Here also RAM to monitor. If you are writing to file, file output stream. Again, we are writing to monitor only. How it will be different? There RAM to monitor, here RAM to monitor. Okay. So it is a console output stream. Okay. Suppose if you write to file, then file to then file output stream, we can say. This is one combination. One more. It is a keyboard. From keyboard, we will type the data received by RAM. Here file. Keyboard to RAM. This is console input stream. RAM to file. File output stream. Okay. Like this. Now, keyboard to RAM, console input stream. That is permanently we store in a file output stream. Fourth one. Here. It is one file. It is one more file. If you copy hard disk to hard disk, but directly it is not done. Again, RAM only. Listen. 3 members not listening. Now, here abc.txt is on file. File to RAM, RAM to file. File to RAM is file input stream. File to RAM is file input stream. RAM to file is file output stream. Then what will happen? See, what we will do generally with Windows also will do. Right click, copy. Then hard disk to RAM comes. Right click, paste. RAM to file comes. But you are going to right click, copy, right click, paste. How it works? Backside one program will be there. That is C program. VC++ program. Windows operating system designed with VC++ programming language. Windows operating system. VC++ programming language, they use it to develop Windows. VC++ extension of C++. C++ extension of C language. C plus oops, that is C++. C++ plus Visual Tools, that is VC++. File to RAM, RAM to hard disk to RAM, RAM to hard disk. That type it works. Okay. Fifth one, it is client, it is server, here network, LAN connection. Okay. No, network. It is network, client to server, server to client. Like will be there. Here, say accepting data from keyboard, input or output, input, displaying data on monitor, output, reading data from file, input, writing data to a file. Client to net. Combinations
Recording in
possible.
progress.
5 combinations. Now, this type of application you can build in this topic. Okay. Right is all. So total number of categories 3, number of streams 6, combinations 5. Total number of categories 3, number of streams are 6, combinations 5. Completed. Total 5 combinations are there. Okay. Say here console input stream, console output stream. Here console file input stream, console output stream. Here console input stream, file output stream. Here file input stream, file output stream. Network input stream, network output streams. Now, here accepting data from keyboard, displaying on monitor. Here reading from file and displaying on monitor. Here typing from keyboard, storing in a hard disk file. Here file to RAM, RAM to file, copying one file to another file. Here sending, receiving, again sending, receiving. Here total categories 3: console input output stream, file input output stream, network input output stream. But total number of streams are 6, but combinations only 5. Reason: keyboard input only. Keyboard cannot receive monitor output only, like that. But touch monitors are different. Touch monitor, you can call it an input device also. Okay. Now, here monitor always output device, keyboard always input device. That is the reason combinations 5. From file we can read also, you can write also. Client to server also, server to client also. But keyboard to monitor, monitor to keyboard not possible. No, that's what 5 combinations. Okay, that's what 5 combinations. These all if you want to build. One library required, compulsory. Without library not possible. Next, note on. There are 3 predefined streams. First one in, second one out, third one ERR. There are 3 predefined streams. First one in, second one out. That is
recording in progress.
Note on. In is an object reference of java.io.input string class. In is an object reference of java.io.input string class. Out and ERR are object references of java.io.printStream class. In is an object reference of java.io.input string class. Out and ERR are object references of java.io.printStream class. It is a reference of this class. These 2 are the reference of this class. The above, all predefined streams are the members of java.lang.system class. The above all predefined streams are the members of java.lang.system or system class. See, if you write like this, class A, class B, here A equal to new B, A. If I write. Now, this small a is a reference of which class? Which class? A class. But it is a member of which class? Which class? B class. That you study now? Small a is a reference of A class, and it is a member of B class. Okay. Now, between A class and B class, any relationship is there? You studied how many types of relationships? 2 types. What are those? Is a, has a. Now give me answer. Has the relationship. Creating an object of one class as a member of another class. That concept is called composition. That is nothing but has a relationship. Now, this small a is a reference of which class? Member of which class? B class. Here, the above all predefined streams are the static members, right? Static members. Static members of system class. That is static is there. Now, here, you observe out is a reference of which class? Print stream class. Out is a member of which class? System class. In is a reference of which class? In is a member of which class? Out is a reference of which class? Out is a member of? ER is a reference of? ER is a member of? Between input stream system class. Any relationship is there? Yes. Which relationship? Has the relationship. Between print stream and system class. Any relationship is there? Same. Has a relationship. These relationships, if you understand, then you will understand system.out.println. That line, it will take half an hour to explain. We'll see on Monday. Okay? Monday, I'll explain about that. Monday, we'll see continuation.